Hello everyone, and thank you very much for joining this live event, which is lesson 14 from the Spring Security Fundamentals stream, and we continue our discussion about tokens with Opac Tokens, Introspection and Blackboarding. Thank you very much for being here with me. If you are watching the event live, don't forget to have a live chat there so you can ask me questions directly in the live chat. And if you are watching the event recorded, don't worry, you can still ask questions in the comment section. And you can also find me on LinkedIn or Twitter, and you can ask me questions there, or you can simply follow me because you'd like to see my reactions or my posts. And with that being said, let's continue our today's lesson, which is again about tokens. And in the previous couple of lessons, we've already covered a lot of things about what OAuth 2 is, and you've seen how can we implement our own authorization server. We discussed about grant types, and we discussed about tokens. And to make a short recap, in the previous lesson you've seen that we have two kinds of tokens. So one of them is the Opac tokens, which is actually like my access card I have here. So my access card is an Opac token because watching it you can't see any information, it's just blank. So once you have a token but it's only a string or a card or something that doesn't reflect any data, then you know it's an Opac token, because looking at it you can't decide if it's a valid token, and you can't decide about what can one access with it. So in order to use an Opac token, you need to actually get the information from somewhere else. And in the previous lesson we discussed about 3 ways where you might see Opac tokens, or how Opac tokens might be used in different real world scenarios that you might encounter. And of course on the other hand, we have the JWT tokens, or the actually known Opac tokens, and the most known implementation being the JWT, JSON Web Token, that we didn't discuss yet. It will probably be part of the next lesson, and that's the token where you can actually find the data. So the data is contained inside the token. Having the token, you have plenty of information, including if the token is valid or not, because as you will see, in case of JWT, we resolve the validity of the token by making use of its signature. That being said, that will be part of the next lesson probably, but now we have to deal with the other 2 scenarios we didn't touch in the previous lesson about Opac tokens. And remember, I have already opened the previous project we worked on in the previous lesson, so lesson 13. And if you remember, actually what we did was at the end we managed to implement both the resource server and the authorization server responsibilities inside the same project. And that is the first approach, but the approach that mostly only usable for an example, or for a very, very fast POC, where you just want to check, for example, your implementation of token store. Otherwise, you will probably in most of the cases have both the responsibilities of the resource server and the authorization server separated in two different applications. So that's why we have to do that as well. So that's why from our 3 scenarios, actually only one of them we've covered in the previous lesson, which was putting both the responsibilities of the resource server and authorization server in the same application, but that's workable only with examples. And now we want to split them, and to split them we need to use one of the 2 other approaches that you've learned in the previous lesson. One of them was the token introspection, where the resource server calls an endpoint on the authorization server to find out details about a token, details about an Opac token, including if it's a valid token or not. And the other approach that I will tell you, it's actually less advisable to use in real world scenarios, but we will cover it, is the blackboarding approach, where you use a shared database. And the usage of shared databases between services is not really considered a good practice, and that's why I would also say you would probably like to avoid it. But I wanted to also tell you about it, because usually it's better to know all your tools in order to know what to choose. rather than not telling you that this approach exists. From my point of view, it's better that I will tell you all the possible approaches, even if it's an approach that you might rather in some cases like to avoid, and like the blackboarding is in most of the cases you'd probably avoid it. I could say that I've seen it in one real world scenario once, but I didn't agree with that. So in some cases maybe you could even see it. I don't say it's not possible at all, but what I say is that most probably you'd like to avoid situations in which you use shared databases. So with that being said, we can now I would like first to start with this project again, the one we've already built in the previous lesson. I will start it and I will recap a little bit of what we've done fast so that you remember the components. And I would also with this application, I would also like to actually answer a question I had about the refresh token grant type, because at some point in one of the previous lessons I remember I had a problem with generating the access token using a refresh token, and I did some investigation on that, and as you will see, it's an uncovered feature in the framework itself. Potentially you could even say it's a bug. I will explain it immediately, but the idea is that with some very small change that's possible, and I will show you how to do that to clarify again also the refresh token. And then we will, from now on, we will actually have to implement always 2 projects per example, because we will have to implement both the authorization server and the resource server. And yeah, that's it. In most of the cases we'll have to implement 2 projects because that's the exercise about. So let's finish with our project 13 and leave it behind, and then we will start with the new projects where we will have to both implement the authorization and the resource server for our examples. I will now start this one, and with starting the example I would also like to clarify little bit again what's all about. So remember, the authorization server responsibility is the one dealing with the users, which means that in the application that has the authorization server responsibility, you always have the user management as well. So that's why we have a user management config here, where we have declared user detail service, of course, and the password encoder, 2 components which we know from the beginning, like from the beginning of this stream, from the first couple of lessons. They are some of the basic contracts of Spring Security, and they represent the user management in Spring Security. And of course we use it the simplest approach ever, so we just store the user in memory for our tests. And I've also shown you how to use an in-memory user detail service when you want to, for example, avoid using the no-op password encoder and use a bcrypt password encoder instead. And then we had the authorization server config, where beside having users, you also had to register a client, because remember from our previous couple of lessons about OAuth, the client itself, which is the application accessing the resources and using the authorization server to obtain a token, also needs to identify itself. So that's why the client, the application itself, also has its own credentials, which we call the client ID and the client secret. And of course we need a scope, and of course we need to provide the grant type, in my case the password grant type. Some of you asked me why do I always use the password grant type, because even I have said in one of the previous couple of lessons that the password grant type is avoidable, is somehow, you could call it, deprecated, and you shouldn't use it when using OAuth 2 for user resources flows. And I want to also answer this question. I use the password grant type only for its simplicity. So remember, now at this moment in lesson 14, I consider that you already have learned well what the grant types are, and you know that any grant type, it's actually only a flow which has the result of obtaining an access token. Now, of course, from now on, I will use the simplest possible, which for the user resources is the password grant type. Even if it's not advisable, it's for us usable in our examples because we spare a lot of time. Imagine if I would have had to use all the time and for all my examples the authorization code grant type, that meant that I need all the time to go through that flow and obtain an access token, and that takes some more minutes. I would like to spare and invest in other topics that you are of course most interested in, because they are new and you need to understand them. So that's why I'm using the password grant type. But again, remember, the password grant type is not advisable in general in a real world scenario. You'd rather in most of the cases go to the authorization through the authorization code flow rather than the password grant type. And I've also added here the refresh token grant type because I would like to clarify how the refresh token can be used to obtain an access token. It's one of those things that because of a bug I will explain now, I wasn't able to do in the lesson where we discussed the grant types, and I want to clarify it now. So that's why I have here in this configuration, I have configured, as you can see, the client. This is actually the configuration we've done for the token introspection, but I will clarify it again with the next project, so we don't mind it. And then of course I had to plug in the authentication manager so that we can use this authorization server with the users from our user configuration here. And in the end, I've made this application as well a resource server just by adding a class annotated with the enable resource server, the configuration class annotated also with the enable resource server annotation. And that being said, I also created an endpoint, and this endpoint is, yes, the endpoint that we will call for test. Now this is working because, and we don't, even if we have Opac tokens, we don't need something special, and it's working just because now both the authorization server and the resource server, they see the same token store, because the same token store is in the same application. But again, this is only usable for examples, so we will have to actually decouple those responsibilities into two applications, and in that case, well, of course it won't work anymore, because then the resource server will need to know the details and will need a way to find the details. I will run this application, where I actually have already run, I see this application, to show you to answer the question about the refresh token. I would like to clarify that, and then I close it, and you will go with me together to the next example to discuss the token introspection. So in the previous lesson, where I have tried to show you the refresh token usage and it didn't work, it wasn't actually me doing something wrong. It was actually the fact that it seems that with some implementation of the Spring Security, the user detail service for the refresh token grant type isn't available anymore, isn't taken anymore from the context. So because of that, you have to actually explicitly set it here, as well as you've set the authorization manager. So when we've tried that in the previous lesson, this line didn't exist. This line is a line that I've added with my investigation previously. What I was expecting and why I was expecting it to work is because usually if you have a user detail service in the context, and I had one in the context, in most of the cases, Spring Security knows to find first and to search first for a user detail service in the context. And it seems that again this thing changed with the refresh token grant type, and because I didn't explicitly use it, it didn't take it from the context as I expected. So that's what I generally consider to be a bug. You could actually call it a lack of functionality, but you can actually call it even a bug. So what I've done to solve this, I have explicitly set up the user detail service. So I did inject the user detail service. No worries about the error. It's only from IntelliJ. It's probably a bug from IntelliJ, but the application works correctly. So you can see that my application started and I can use it actually. Well, the console is here and the application actually started, and you can see that it did start and I will be able to use it. I have injected the user detail service and I have set it at the app explicitly here. So what I can do now is go to my Postman, open a tab and call the token endpoint to obtain a token. And you already know how to do that. So localhost 8080 OAuth token, and I use the grant type, which is password grant type. And then I need to also specify, because it's the password grant type, I need to specify the user, and I need to specify the password of the user. 1, 2, 3, 4, 5, if I remember correctly, that's what I'm usually using. For example, scope read. And of course the client needs to authenticate, so I use basic authentication, and these are my client credentials, client 1 and secret 1, again if I remember correctly, and calling that I will obtain the access token. And because I have also added a refresh token, I will also get in the response a refresh token. So again, repeating what I've said in one of the previous lessons, when you have a user refresh token, you basically use it to avoid storing and resending credentials over network, and you can actually use that to also avoid re-authenticating the user when you use the authorization code grant type. So what should I be able to do is actually use this refresh token here to obtain a new token without needing again the user's credentials. So I call again the token endpoint, so that would be again localhost 8080, so OAuth token, but I do specify as a grant type, in this case of course refresh token, refresh. I have to be careful how I write it, because otherwise it won't work, of course. And then I need to specify the scope, and then I need to specify as well the value of the refresh token. So refresh token again, which is the value of the refresh token I got from the previous call. I copied it from the response, I put it here. I use again the authorization, the basic OAuth of the client. The client still needs to authenticate to obtain a token. And when I send this, then I get the same response I got for the password grant type. But observe the difference here. Instead of rewriting the username and the password, I have no username and password of the user in this request. I only have the refresh token, which replaces the need of having the user's credentials. So that's why I use the refresh token. As you can see, this worked for me now. This is the same call I've done in one of the previous lessons. It didn't work at that time because, again, it seems you really have to, it's a bug in the framework, you really have to explicitly specify the user details service, and it won't take it from the context. Even if you have it in the context, it didn't take it from the context. That's why it wasn't working. And I hope with this I have clarified this subject as well, and I can continue our lesson with discussing the token introspection, which is the first real way we would use an Opac token actually, and let's actually see it again. To do token introspection, which in a couple of words means that the resource server calls the check token endpoint on the authorization server. Remember our diagram now. So I have a resource server, and the resource server receives the token from the client. The resource server now has an Opac token. The Opac token is blank, doesn't say anything. So the resource server needs to know if the token is valid and some more details about that. How does the resource server find? The first option, token introspection. It calls the authorization server. In case of the authorization server, remember we have an exposed check token endpoint. It calls the check token endpoint and finds if the token really is a valid one. So that's the thing we'd like to do. So let's start with a new project here. I will create a new project, Spring Security, Spring Initializer, and it's Spring Security C14. I would also now add an AS, which is Authorization Server, because remember, in these examples, we'd really want to have both responsibilities separated in separate applications. Otherwise, that wouldn't prove you that this really works. If I would use the same application, you could say that it's the same thing as I've done in the previous lesson. So I really want to prove you that now we really use token introspection, and it's a different implementation than what we've used in the previous application, in the previous lesson, where we had one application defining both responsibilities. So I do create the Spring Security C14 authorization server, and that means we need the web dependency because it's a web application, and we need Spring Security because we learn Spring Security. So and we need OAuth cloud, the OAuth cloud response dependency as well, because we implement the authorization server responsibility. And basically we don't need anything else, because the first implementation using token introspection doesn't use a database. But in the next one, where we'll discuss the blackboarding, where we'll also need to add the driver manager for the database. But let's now focus only on this authorization server. So fortunately, this is very simple. It's a very simple authorization server. I have to wait a couple of minutes maybe here to for IntelliJ to finish the indexing, and then what we'll have to do, we'll only define here the configuration for the authorization server. We'll only define that. We'll have to expose the check token endpoint, which is done explicitly. Remember that the check token endpoint is denied by default, so you can't access it. But you learned in the previous lesson how can you enable it. You can even make it completely permit all, or you can use these authenticated. We'll directly use these authenticated in our example now. And I have the config here that I have to create, and inside the config package we'll call this user management config. So this is where you'll basically declare the user detail service and the password encoder, as you've already learned. And here is also where you extend the web security configurer adapter, and you will use that to expose the authentication manager. So to be even more precise, you actually have the same user management configuration class as you've already done in the previous lesson. So to save some time, because we've already done this in the previous lesson head to tail, allow me to do some copy-paste programming, which usually is an anti-pattern, and copy-paste the implementation, so that now I have the same user detail service exposing a user bill. You know this, you've learned this from the first lesson of this stream. And then I have a password encoder, of course. I make sure I encode the password using the same password encoder, and I do expose as a bin in the context the authentication manager, so that I can actually set it up in my authorization server configuration. That will be the next configuration class we are working on. So with having this user management config, which is clearly something very plain, and something that we've also implemented in the past couple of lessons, we can continue further with writing the authorization server config. And the authorization server config, of course, needs to be a configuration class, so I annotated it with that configuration, and then I do enable authorization server, not resource server. Resource server will come later. And then I have to extend the authorization server configurer adapter, which is the class we use to do different configuration we need to do, including setting up our clients. And again, to be very fast, because it's the same thing we've actually done in the previous lesson, I would like to save the time and actually take the configuration from here and use it the same way. I will re-explain it, however, so that you remember what we've done here. So it's just having the authentication manager that I set up here. So you remember, we put it in the context, we inject it from the context, and we set it up in the authorization manager configuration. The user detail service, I explained you, it's only needed for the refresh token. So say you don't use refresh token, you can even avoid writing this. You don't need to set it up explicitly. So for the password run type, it's enough to have it in the context. That's why I said it's most probably a bug that for the refresh token that doesn't work. And of course, you need to expose the introspection token endpoint, which is that endpoint somebody can call to obtain details about the token, the Opac token. And that somebody in our case is the resource server. The resource server needs that. If you specified this, the expression is authenticated, that means that the one calling the token introspection endpoint needs to authenticate using some client credentials. So that's why we will have to also add some credentials for our resource server. The resource server in this case also becomes client in from the perspective of the authorization server. Of course, we also have the easy way around where you can use the permit all. As we've also done in the previous lesson, using permit all instead of is authenticated, anybody can call the check token endpoint without needing any credentials. So that actually means that in this case you wouldn't need to refer somehow to the resource server. But I've chosen to implement here the most difficult scenario with the is authenticated, because yeah, if you know how this works, then the permit all is the same thing, but just that you don't use the credentials. So that should be fast enough for you to change it to permit all if you really want to do a permit all. And again, what I've said, if you use the is authenticated, then you need to grant some credentials that will be used by your resource server. So same as you've done with a normal client, you have to do with the resource server. The resource server becomes client as well. So I will append using some new client here, which will actually be representing my resource server. So let's say with client resource server, that will be the username, the client ID used by the resource server, with a secret, and then whatever secret you'd like to use, doesn't matter. It can be any kind of a password here. And if you do so, if you actually only need to use it for the resource server check token introspection call, you don't need to specify anything else, because it's not like a client that will access a token, it's only calling the check token endpoint. So that's why you don't need to specify grant types, you don't need to specify scopes, you don't need to specify anything else. The two credentials are enough for your resource server to be able to call the check token endpoint. So what happens now is that if I start this application, and allow me start this application, I will try it from Postman, and I will make sure from Postman that this application really works first. I will test first my authorization server. And when I decide that this actually works accordingly to what I want to implement, then I will go to the second application, which is my resource server, and I will implement a separate application which will take the resource server responsibility and will use the token introspection to obtain the token details from my authorization server. So you see, I've managed to start my application, which means I will go back here and I will test again that this works. So you see, of course, the refresh token disappeared because I've taken out from this application the resource server grant type. So you only have the password grant type. You won't see a refresh token in this case. So I can't use this tab anymore in this case. I can only use access tokens. But I want to make sure that I can call the token introspection endpoint. I want to be sure that my resource server can call, using those credentials I've set, the check token endpoint to get details about the token. It will need that in order to validate that the tokens are fine, that the tokens are valid. So in order to do that, you remember we've also discussed in the previous lesson that we use the check token here, not the token key. That's something else we'll discuss later. The check token endpoint, which is one of the exposed endpoints of my authorization server. So I'm going back to my Postman and I will call that. So localhost 8080 OAuth check token, and then the token and the valid and a valid value for the token. In the authorization, I will use basic, but make sure that, of course, it will probably use with this as well. You see it's working. I got the details, but the plan is I won't use the same credentials for my resource server. I never do that, never share credentials. I've seen that mistakes in some real world scenarios, and that's pretty bad. I've seen people registering one client and using multiple applications with the same credentials, and that's bad. So make sure that you really have different credentials. So let's make sure in our case that our credentials that have been desired for the resource server work. So it's resource server with 1, 2, 3, 4, 5. So resource server with 1, 2, 3, 4, 5. That's what I want to work. So it works okay, which is of course expected, but I wanted to make sure that I can use those credentials because that's what I will place into my resource server configuration, and that's how I expect my resource server will be able to call this endpoint and find out if the token is valid or not. So that being said, and knowing that we have implemented now some correct authorization server, let me close the previous example so I spare some resources. And I will open now, I will create another project which is actually this resource server, and I create the Spring Initializer, and I say Spring Security, it's still C14, but it's the RS, which is the resource server. Still version 14, so the same thing. This is the pair of authorization server and resource server for my example. The resource server is also on web application, so I'm adding the web dependency. It uses Spring Security and it uses Cloud OAuth 2 dependency, and that should be again enough for me because I have no database. I have nothing to worry about in regards to anything else. So these dependencies should be fine for my example. So being said, then what was the resource server? The resource server, again, I want to be very clear. It's nothing more than the backend we secure. This resource server is the backend for which we implement the security. It's how the responsibility is called in when discussing it in terms of OAuth 2. So here is where we have the endpoint one would like to call. That one is usually the client to use it by making use of an access token that was issued by the authorization server. So that's why here, first of all, I will make sure I have the endpoint that represents my test, the thing I'd like to test. So controller, and let's create a controller. So remember, in the previous lesson, these two were in the same application. Now we have separated them. Hello controller, and that's be just a normal REST controller and a very simple endpoint. It's enough for us to prove our implementation. So hello and get mapping and the endpoint. Cool. So that's it. And now my configuration. I do here package config, and this has to become a resource server in terms of OAuth 2. So to become a resource server, I'll call it resource server config. I make it configuration class by annotating it with that configuration, and I enable the resource server by doing the enable resource server. So that should be it. Of course, it can't run on the same port. So first of all, I also make sure I do a server port here, and I change the port to some other port because I need to have both the applications running in parallel, so they have to work on different ports. One was 8080 and that will be 9090. Of course, if I run this application and I try to access the hello controller endpoint, it shouldn't work. Do you see? It shouldn't work because how can my resource server actually know that the token would be valid or not? Let's first try to do that, and let's prove that it doesn't work. And let's make sure that we understand why this doesn't work, and then we'll make it work by using token introspection. So that's the plan. So I did actually start it. My resource server started on port 9090. I'm going back to Postman. I'm opening another tab, and I'm trying to call the hello endpoint. So localhost 8080 hello, isn't it? This is it, and now we do send it, and we have unauthorized, and I will even do this thing. I will actually send the request to my authorization server. I will copy the value from here, put it here and do headers. I will add the authorization header. I will do a bearer, and so I do respect the way it should be called, and I still get unauthorized. And the reason is, even if maybe some of you are confused now, and that's what I want to clarify. Why, by sending a valid token, weren't you able to call the hello endpoint? Like this worked in the previous lesson, isn't it? Why in the previous lesson it did work and now it doesn't work? Because in the previous lesson, both of them were in the same application. So when I generated the token, the resource server was seeing the same token store as the authorization server. Because they were in the same application, both of them had access to the same token store. And that's why in the previous lesson, this worked without me doing something special. But now it isn't working anymore because I have separated the responsibilities and I have two different applications. So now I really have to do somehow, I really have to implement somehow my resource server to be able to validate this token. It has no way now to know that this token really is valid. When we'll discuss about JWT tokens which are not opaque, in the next lesson you will see that the resource server may see that it's a valid token or not in case of a non-opaque token, but with an opaque token, which again means it's blank, it's no information there, without calling somehow the authorization server or finding somehow the details about it, the resource server cannot decide this is a valid token, so it will actually not authorize me. So let's make sure we use token introspection. It's very easy. Instead of having the same token store, we will just provide the resource server an endpoint it can use to validate the token. And you already know which that token is, which that endpoint is. It's precisely the check token endpoint that we have seen and we have tested previously. So I will precisely take this as it is here in my Postman. We used it, we know it's working, we know these credentials are valid. And what I'm doing, I'm going to my resource server configuration and I'm searching for the token info something endpoint. This is the OAuth to resource token info URI. Preferably you also specify HTTP in front of it, a complete URI. And then if I would have specified permit all, that should be it. Automatically now my resource server should know to call the check token endpoint and to validate the token. But in my case, because the token info URI is authenticated, that means you need to use basic authentication and some valid credentials, I will need to specify these credentials as well. That will be OAuth to client something. Let me see if I remember. Client ID or something like that. Client ID and client secret. So that is resource server, and then we have a very similar property to specify the secret in this case, which is 12345 if I remember correctly, is the one we've tested here. Resource server and 12345. Okay, I think it's fine now. So now I do actually start again my resource server and we will redo the flow. And if I didn't, for some reason, I don't know, if I didn't do something wrong, hopefully I didn't, then this should actually really check my token and I should be able to call the hello endpoint. So going back here, I generate a token. Well, it's the same because they didn't expire, it will generate me the same token. But anyway, I copy it to be clear and I'm going here and I'm actually copying it again. I still have a two one. So this actually means that something didn't work well in my case. I'm not precisely sure why, because I think I did actually do whatever was needed, but yeah, it simply seems that I actually implemented something wrong. But I will try it again just to make sure. So again, I will see resource token info URI, and this is the check token, and I have the ID and the resource server, and I have the enable resource server, which is correct here. We could also extend the resource server configurator, but that should not be needed in our case because I didn't override anything. Are you hard coding your URLs? Can we use Eureka server or Zool to make them flexible? Yes, but you just put their two names, which is Eureka server and Zool. They are two different Netflix implementations that do two different things. So my answer is you can't use Zool because that's a gatekeeper. So that's a gateway actually implementation. So no, you can't use Zool because it does something else. It has some other purpose. Eureka, however, is a discovery server, which means that yes, you can use that. But I would actually try to use that in a separate video if you allow me, because, well, you see, Eureka is actually, at the moment, if I remember correctly, only maintained and not anymore developed by Netflix. I hope I'm not wrong. So that makes it an library that you might probably not really like to use in the future. And what I've done in the past, where actually in my previous projects, instead of using Eureka, in most of the cases I actually used the discovery possibilities of the platforms I have used, like OpenShift. So yes, in my example, please allow me to actually hard code passwords and URLs, because if I would try actually to teach you the same things and doing also storing passwords in vaults and so on and so forth, you will probably not understand anything about what I'm doing. So what I prefer to do, well, in my approach, I actually prefer to actually separate things that I teach so that you can really understand and you can really focus on one subject. Otherwise, if I don't do that, you might not be able to focus on one subject and you won't really understand what I'm doing here. So yes, you can use Eureka, it's a discovery library, you can implement a discovery functionality for that. Zool is a gatekeeper, it has nothing to do with that, you would only implement a gateway with that. You could do discovery through many other approaches, so it's not necessarily to do with Eureka, but that's another story and it's another lesson. So I hope that answers your question. Good. So I'm really still concerned why this doesn't really work for me, and I'm not actually sure at what I did wrong, but I'm pretty sure I did something wrong. I'm probably pretty stupid. It's not clear for me what. So I will actually try to see what is wrong in my case, see why it's not working. I think maybe the easiest way would be actually to make it first accessible without passwords. I'll try to do some debug on it. Let me do some debug on it. What I will do, I will replace my is authenticated with permit all, and I will check if this is not actually my fault, like this, if this is not actually my credentials with something wrong, and if this is not the case, then I will actually try to find out what the case is, because I'm pretty sure that I've implemented everything right. So I'm again not little bit concerned why it's not. So that should now work. Of course, invalid token, because I've restarted the server, so now it will generate a new one for me. I will first check in Postman. That's how I'm always doing. I'm first checking in Postman to make sure that one component is working correctly, and you see I can actually access it without authorization. And what I will do now, I will do the same thing here. I will restart my authorization server, sorry, my resource server. And here it should be that I don't need this anymore. So again, I have security auth resource token info URI, and then check token. So this is right. Again I'm not sure what I'm doing wrong. Okay, it started now, so I can just go back here and I will try to, oops, I pressed something wrong, sorry. I will try to test it again. So I do send my credentials. Oh, did I close my server? I think I've actually closed my authorization. Yeah, I've closed it. So let's start it again because of the permit all. It seems that with all this time I didn't calculate it. Actually, I didn't calculate correct my time, so to do today the JDBC part, and because I'm actually wrong with this, and I'm not sure why, because it should be a simple example, but you know how it works. It actually happens that it seems that it happens sometimes. You even screw it with simple examples. Yeah, I'm still not. Authorization is correctly written, bearer is correctly written, the token is fine. Yeah, I will check it out, and again probably something that I'm doing wrong, because everything else it's working correctly, and you can see the authorization server is not a problem. My only problem is with the resource server. So here is where I'm actually doing something wrong, and it's not with the credentials but something with the configuration itself. But I've actually implemented everything like fine. So let me see. The only thing I could actually maybe be going wrong, it's actually having the configure method is authenticated by default, and the resources here, I'm not sure if I actually have to do something. So I actually think everything is fine. So that the token store here will be automatically created. Yeah, again. Now I will again go over this example, because losing time with it is still clearly not good for any of us. So sorry for this, but it seems that again I screwed it, and that sometimes happens to me as well. But I will try to explain what actually should happen. So you see here what we will actually do in our next next lesson, because we don't have a lot of time now. So we will actually configure the token store for our resource server as well. That token store, in my case, what I expect is that it should have been automatically created only because I have specified my token info URI here. I expected that the resource server would automatically have a token store, but maybe that's where I'm wrong. Anyway, the token store that we have also discussed is actually the contract the authorization server uses to store the tokens, but also the contract the resource server uses to get the tokens from. And in the case of the token store, when it's on the resource server side, then what happens is that the token store implementation is actually used to read the token. So the token store doesn't only have the responsibility of storing the token. That's what happens when the authorization server generates the token. It somehow stores the token, and if you look in the contract of the token store, you will probably not need to implement it yourself usually, but you could even implement your own token store. Then what happens here is that the authorization server stores the access token, and then in the token store, and then what happens is that the resource server reads from the token store. So the same token store is somehow the middle point where the authentication and the authorizations intersect in case of the Auth2 implementation. So yeah, what we will do is actually we will start by using our own simple JDBC token store that will allow us connect to a database and store the tokens in a database from the authorization server side, and then read the tokens from the database on the resource server side. So that's how we'll basically implement our blackboarding approach. Blackboarding meaning is like a blackboard. The authorization server stores, like, writes the tokens on a blackboard. So the database is compared in the blackboarding with a blackboard because the authorization server writes the tokens on the blackboard. It's like writing them in the database, and then the resource server takes them from the database and puts them in and validates them by that. So yeah, that's what it happens in general. And yeah, I'm still yeah, I don't know, again, hope is not again a bug, but in this case it's a too easy example to be a bug. It's only a bug in my mind, only probably something that I'm missing. It's very close. I will take it after this video, and I will make sure I will upload a correct implementation. Like if something is missing, I will change it, and you will have a correct implementation, and you will find in the comments what I was doing wrong, and I will take it in the next lesson again, and I will tell you what I was doing wrong and why it's not working. Because what I was expecting else actually is that now, because my resource server actually has, oh, that's what I'm doing wrong. It's not 8080, it's 9090. Come on guys, nobody's seen that. So my implementation is correct. I was just actually calling the different port. My resource server, it's on 9090, not on 8080. Come on, that's what happens when you do things after too many hours of work. So so yeah, the implementation is correct. I probably don't have to change a line of code. This is just my calling from Postman was using the wrong port here. So I was actually trying to call the hello endpoint on the authorization server instead of the resource server. That's what was wrong. That's stupid of me. Sorry for that. So yeah, let's first make sure it started completely. No, it didn't start completely. Because of, I have no idea why, but I will actually, I will actually, what I want to do is revert my changes completely, because I don't know what changes I've done. I want to have the simplest configuration, and I'm actually even quite sure that will work with the resource server and the password as well. Yeah, I don't know why I dubbed myself, because actually is authenticated. Oh and I will restart this and test it again. And yeah, again, yeah, probably it was only this port that was wrong. So that's actually, my implementation should be correct actually. Cool. Okay, let's start now both applications and make sure that they start, and then test them again. But unfortunately, I've lost too many minutes with this, so I will have to move the blackboarding to the next lesson. Sorry for that. It's only my fault. So again, it sometimes my mind doesn't work properly. I missed the port there. Cool. So so that is, now I get the token, and then I will copy it again. I will make sure that this works. I always do that. I do recommend you always do that as well. Make sure that one component works before trying the other. So we see it works now, and then I try the same token here, bearer token. Did I start the resource server? Actually, I'm not sure. No, I didn't. So let's start the resource server actually before trying anything else. And I have my controller here. Hello controller, everything should be fine. Okay, application started, port again 9090, so that was it. And then I do have bearer token. And that's it, finally. So yeah, it wasn't my implementation, the code was right, the testing was wrong in this case. And Yeah, that's good because I was really wondering what I was actually doing wrong, and it seems that I was actually not doing anything wrong in the code. The code was working properly. The devil is in the details. Yes, probably. So something happens something happened with me, and I was actually missing the correct port here. In the previous lesson we had the same port because it was the same application, but now we had two different applications. And you see that basically, yeah, maybe we can actually try to take this out or simply change its value. And if you try it without the authorization, of course you will have a 401 unauthorized. So yes, the authorization works correctly. It really forces you to have a correct token. So if you don't provide a valid token, you have a 401, and you have to provide a valid token. And then at least now it's almost done this lesson, but I managed to explain and to prove you a correct implementation of the check token endpoint and the introspection endpoint. It's one of the two things I want to discuss today. In the next lesson, we will discuss and compare the check token introspection with the blackboarding approach. And I will show you how you can use blackboarding. Again, even though blackboarding is not advisable in real world scenarios, I prefer to give you all the existing tools, and then you will decide what and how, depending on your system, if it's right or not for your implementation. And then, of course, once we finish with this and we've discussed the Opac token, we will go to the JWT, so the non-Opac tokens. And of course, with non-Opac tokens, we'll use the worldwide spread used implementation that's called JSON Web Token, or JWT shortly. And we'll use the JWT implementation, and I will show you how to use that, and I will teach you everything you need to know about JWTs, which is it will pretty sure happen to encounter in real world scenarios. They are very often, they are much more often used than the Opac tokens, but again, you have to really understand the whole mechanism of OAuth, to not only one kind of token and one kind of approach. Do try to understand all the approaches. It will really help you, especially if you are going to work as a, for example, development consultant. You need to know not only one approach, you need to understand all of the possible approaches and be able to compare them in terms of everything like performance, security, maintainability, and so on and so forth. That would really help you. And of course, as an architect, that would really help you, because again, as an architect, you need to see everything from up above, from the top of the mountain. So if you are an architect, or if you are going to be an architect, you need to know in details all these examples, not only understand JWT, and that's all. That being said, thank you very much for listening to me, and I'm happy that in the end I managed to see that it wasn't my coding problem fault. It was just a problem with me calling the endpoint. Sorry for losing maybe more than 10 minutes of this video with my stupid mistake, but sometimes this happens. And I hope you still enjoyed the lesson, and I hope to see you there for the next lesson. By the way, that might be in a couple of weeks from now on, because next week, I'm not sure if you are aware, but next week we have Java Day. It's 25-year celebration of Java, so happy anniversary Java. I will be involved in a lot of events and other presentations, so I will probably cancel the Friday lesson, but I promise